the heat energy is transferred from high temperature to low temperature according to zero law of thermodynamics is when the temperature are the same, then there's no heat flow. They call thermal equilibrium. So heat energy is in transit. Usually, internally, is called Q. When a heat is in an object, in a internal, what we cause. So this one is basically heat. In these cases, heat and the first law of thermodynamics. So what does Q when it's stored inside a person, or Q inside a object? Q will cause the temperature go up. When Q is an internal energy, then temperature will go up. So suppose something is burned, supply the heat into the water. The water temperature will be rise. So that is generally the case. So we have to define what is the heat energy unit. Unit of heat energy. Unit of heat energy, in generally, we give a unit for heat is called calorie. Calorie is a unit of heat. Then we have to define it. So 1 calorie is the amount of heat energy. Amount of heat energy. Amount of heat energy to raise the temperature, to raise 1 gram of water. 1 gram of water. 1 gram of water supposed to be 1 degree, 1 gram of water by 1 degree Celsius. So sometimes the people do the experiment, specify it particularly. So what it does is the temperature raising from 14.5 degrees Celsius to 15.5 degrees Celsius as the requirement. So this is very important for us to know. In general, 1 calorie equal to 1 gram of water raised 1 degree Celsius. So if you do that calculation, Q equal to M C times T final minus T initial. Now all this has to be in Celsius. This is a mass of water. Mass of water. And this is here is the temperature difference. Okay. Now the other things we have to know for sure is important is this particular value. This one is that we call specific heat. This one is very important for our, or what we call our thermodynamic system. Specific heat is basically is determined the capability of specific heat is capability of a matter to hold heat. The largest the specific heat is the largest capability to hold on the heat. So in this cases, the specific heat for water 1 calorie per gram per degree Celsius. This is how you designate. Now the other one, the specific heat is getting less. So what it means when it's less, physically it means less. Suppose we like to say specific heat for copper, in that cases is equal to 0.092 4 calorie per gram per degree Celsius. Now, you using this specific heat of copper compared with this specific heat of water, ladies and gentlemen, so water have a 10 times the holding power, or holding heat power than copper. So what does that tell you? If you have a copper, you will burn the heat from one end, pretty soon going to transmit it to the other end. It cannot holding the heat. The same thing with aluminum. If you look at the chart, the aluminum is 0.215. 0.215. The specific heat for aluminum is degree Celsius. By the way, again, comparatively speaking, this is 1.0 and this is 0.215. So aluminum cannot holding the heat either. As soon as you burn the aluminum on one side, it transmitted to the other side. That's why we're using aluminum for cooking ware, so it can cook. This is a somewhat a definition. So C can be equal to Q divided by M T sub F minus T sub I. This is how you find the specific heat. So this is belong to the section 17.2 section. Okay, to do the heat experiment, we gotta have a special tool. The special tool, you look at it, the special tool is very simple. The special tool turned out to be a double can setup. Okay, this setup turned out to be this setup. It has a name for it. Is called calorimetry. The way they do the calculation, calorimetry. This is a knowledge. The instrument we call is try to measure specific heat. Is a tool, in which cases is double can. So here is a can that have an inside can and outside can. This is a inner can, and this is an outer can. This is basically the calorimetry setup. Of course, we cover something here. So what is between the two cams? That is called A. Ladies and gentlemen, this is the key for you to take the advantage of it. The air is the best insulator. Air is